Alright, ladies and gentlemen, welcome back to my YouTube channel, and it's Kasiligan Vlogs, and we're going to talk about Fibonacci sequence and the golden ratio. This is mathematics in the modern world. So the history of Fibonacci. Fibonacci was his nickname, which roughly means son of Bonacci. His real name was Leonardo Pisano Bogoglio, and he lived between 1170 and 1250 in Italy. So the concept of Fibonacci's rabbits is that Fibonacci first noted a sequence when pondering a mathematical problem about rabbit breeding. Beginning with a male and female rabbit, how many pairs of rabbit can be born in a year? The problem assumes the following conditions. First, begin with one male rabbit and female rabbit that have just been born. Rabbits reach sexual maturity after 1 month, and the gestation period of a rabbit is 1 month. After reaching sexual maturity, female rabbits give birth every month. A female rabbit gives birth to one male rabbit and one female rabbit, and rabbits do not die. So this is best understood in this diagram. After 1 month, the first pair is not yet at sexual maturity and can't mate. At 2 months, the rabbit have mated but not yet given birth, resulting in only one pair of rabbits after 3 of the months. The first pair will give birth to another pair, and the resulting in the 2 pairs. At the 4th month mark, the original pair gives birth again, and the second pair mates but does not yet give birth, leaving the total of the 3 pair. This continues until a year has passed, in which there will be 233 pairs of rabbits. So as you're going to look at here, so this is how we're going to present that one in the diagram. So Fibonacci's appearances. So these are the appearances that we can say that Fibonacci is being applied here. So there is such a meaning of Fibonacci, or that's how we say there is, mayroon po itong parang nagkakaroon po ito ng Fibonacci sequence based on his part. Okay, Fibonacci sequence. The Fibonacci sequence is a series of numbers. So starting with 1, 1, 2, 3, 5, 8, 13, and 21, and so on. So how did we come up with this part? So the next number is found by adding up to the 2 numbers before it. The second is found by adding the 2 numbers before it, 1 plus 1. So this is 1 plus 1. So if you have 1 plus 1, that is equal to 2. So this is the next term. If we're going to add here, this is 2 plus 1. That is the third term. So this is 3. So we have here 3 plus 2, that is equal to 5. And 5 plus 3, that's equal to 8. So that is just by adding the 2 numbers before it. So if 3 is found by adding 2 numbers before it, that is equal to 3 and 5 and so on. So that's how we are going to talk about Fibonacci sequence. So by adding the number before it. Alright. So we have here Fibonacci rules. A Fibonacci sequence can be written recursively as f1 and f2 is equal to number 1. And fn is equal to fn minus 1 sub fn sub n sub 1 plus f sub n minus 2 for n is greater than or equal to 3, where fn is the third number n, and fn minus 1 is the previous term, and f sub n minus 2 is the term before that, n minus 2, that is n minus 2. Okay, so example, consider the sequence 1, 1, 2, 3, 5, 8, and 13. Use the definition Fibonacci's numbers to find 8 Fibonacci numbers. So by having the formula is, we have here the formula, Fn is equal to Fn minus 1 plus Fn minus 2. So if we're going to have this one, so you're going to look for the 8 terms of the Fibonacci. So F8 is equal to, what is F? This is F8 minus 1 plus F8 minus 2. So we have here F8 is equal to F7 plus F6. Alright. So we're going to have this one. This is first term, second, third, fourth, fifth, sixth, and 7. So therefore, if our F7 is equal to 13, so you're going to add it by 8. So F8 is equal to 21. So the next term here is 21. So that is how we're going to make use of Fibonacci in definition. Alright. So Fibonacci and golden ratio. So Fibonacci is related with golden ratio. So let us have first, what is a golden ratio? A golden ratio is, in this case, is we're going to divide the two numbers, subsequent numbers or consecutive numbers, divided by the smaller number here. So example, we have here, in this case, so we have here 3 divided by 2. In order to us to get the relationship between Fibonacci, we are going to have this like this. So 3 divided by 2, that is equal to 1.5. So we have here, next is 5 divided by 3, that is equal to 1.666, and ellipses. Next we have here 5 divided by 8, we have 8 divided by 5, that is equal to 1.625. And we have here 13 divided by 8 is equal to 21 divided by 13. Okay, 21 divided by 13, that is equal to 1.6153846158 based on calculator. Next we have 34 divided by 21. So calculator, we have 1.619047619005. So we have next is 3455 divided by 34. So we have here 1.61764705882. So next is 89 divided by 55. So 89 divided by 55 by 1.04705882353. Next is 144 divided by 89. So 144 divided by 89 is 1.617977 Next is 233 divided by 144. So the result is 1.618055556. So next, 377 over 233. That is equal to 1.618025755755107. So if we're going to observe the Fibonacci come out, the golden ratio rather, come out in this part, if it is getting higher, So therefore, the golden ratio is 1.618, approximately 1.618, because it closer to 1.618 when going to divide it by higher. So the golden ratio is this one. So the golden ratio is equal to 1 plus the square root of 5 over 2. If we're going to calculate that one using calculator, here, alright, I'll just calculate 1 plus the square root of 5 over 2. The result is, this is the golden ratio based on calculator, 1.61803398875. Okay, so this is the golden ratio, is approximately 1.618. So what's the use of the golden ratio in relation to Fibonacci? So let's have this part. So we have here the sequence. So example, if we're going to use Fibonacci, if this is term 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So if we're going to make use of 14, the 12th term, and we're going to find the 17th term. Alright. Using the golden ratio, which is approximately 1.68, that is equal to the phi. Alright. So this is the phi here. So the golden ratio of this one is equal to, if we're going to have F17, just have 144 times the golden ratio, which is 1.618, and if this is F17, so if this is F12, so this is, the remaining is 5. You need to raise it by 5 because the remaining is 12 minus 17, that is equal to 5, because you're going to raise each term by 5, each term by 1.68, then the remaining is 5. 12, then to 5. Okay, so if we're going to calculate that one, so we have here the result 144 times 1.618 quantity squared, now raised to 5. The result is 1596.81674604925. So this is approximately 1597. So that is F17. If we're going to use our manual method, so we have to find the next term. Alright. So the next term for this part is, if we're going to add here, okay, so add 377. Okay, we are going to add 377 here. So this is number 14. So 377 plus 2233. The result of this one is 377 plus 233 is equal to 601. So 610, this one. So the next term is 610. The next term is, we're going to add 377 plus 610. We have 987. And next term, if we're going to add this one, the result of this one is 1597. If this is our 14th term, alright, this is a 14th term, so 14th, 15th, 16th, and 17th. So therefore, we could say that the result is in relation to the golden ratio, which is 1.618. So this is the golden ratio. So this is how we're going to make use of this one. But take note The formula for Fibonacci, because this is in decimal point, still we have here decimal, because this is approximately to this part. So if we're going to solve that one using Fibonacci, the formula is Fn is equal to 1 plus the square root of 5 raised to n minus 1 minus the square root of 5 raised to n over 2 raised to n square root of 5. So this is the formula for Fibonacci. So this one I just presented here because I want you to know that the relationship between the Fibonacci and the golden ratio, by just multiplying the next term would come out. That's the relationship between Fibonacci and the golden ratio. But if we're going to calculate that one using calculator, Fn raised to F17 is equal to 1 plus the square root of 5 raised to 17 minus 1 minus the square root of 5 raised to 17 over 2 raised to 17 the square root of 5. We're going to calculate that one using calculator presented here. The result is 1597. So this is our F17. So we could just immediately solve using calculator. We need scientific calculator as well. Alright, so that's the relationship between Fibonacci and the golden ratio. So the concept of golden ratio. So what is the golden ratio, by the way? So the golden ratio is when we divide a line into two parts so that the longer part divided by the short part is also equal to the whole length divided by the long part. So take note, this part is A and this is B. A is greater part and this is the shorter part. So the golden ratio, the property of the golden ratio, this is the phi, which is the phi of this one. So this is the phi. So if the phi is 1.68 something, so the golden ratio states that A over B is equal to AB over the A. So that's the golden ratio. So what's the concept this one? So the golden ratio is many application to this one in a real life situation. So let us have the concept of golden ratio. Let us have first here, alright, if this is the line segment, okay, assuming this is a straight, okay, assuming this is straight, if we're going to cut this one in a measure of longer and the shorter cut, let us assume that this first cut is 0.720 and this is 0.208, right? Alright, so the golden ratio states that A over B is equal to A plus B over A. If this is our A and this is our B, so if A plus B, that is equal to 1. Okay, so A over B, so we have here 0.720 over B, which is 0.280. By the use of calculator, we have 2.571. So A over B, that is A, this one. Next we have here A plus B. A here is 0.720 plus 0.280 divided by, we have here 0.720. So we're going to divide that one using calculator. So A plus B, so 1 divided by 0.720 is equal to 1.389 and so on. Okay, so next we have here, if we're going to have this one using this part you have here, let us assume that if we're going to adjust this part, so let us have the next side is 0.713 and 0.187. If we're going to adjust this one, so we have here 0.713 over 0.187. So the result of this one is 2.490. And if we're going to divide 0.713 plus 187.187 over 0.713, the result of this one is 1.402. Okay, so the concept of golden ratio is that when you divide, we're going to look for a ratio which is A over B and A plus B are equal. So let us have another part. So let us have first this part. So let us divide this one, and this is the longer side, which is 0.618. And we have here 0.382. So this is our A, and this is B. The total of this one is equal to 1. So let us have first is 0.618 over 0.382 is equal to 1.618. Next we have here 0.618 plus 0.382 over 0.618. The answer is 1.618. So therefore, we could say that this is approximately, this is our golden ratio, because A over B is equal to A plus B over A. So therefore, this is the golden ratio. So that's the concept about the golden ratio. The A over B is equal to A plus B over A. That's the concept of golden ratio. So the property of golden ratio is A over B is equal to A plus B over A. So how could we get the golden ratio, which is this, the golden ratio, that's what stated, is equal to this 1 plus the square root of 5 over 2, which is our phi. So our phi is equal to 1.618 and so on. So this is the golden ratio. By the use of this golden ratio property, we could derive the golden ratio. So we have here A over B is equal our phi. Alright, our phi here, A over B, our phi. And next, if we're going to simplify this one, this is A over B is equal to A over A plus B over A. So this is 1 plus B over A. So therefore, we have here A over A is equal to 1, and B over A is the inverse of this part. So therefore, 1 over the phi. So 1 over phi. If we're going to have this one, an equation, if we're going to substitute here, so this is the phi is equal to 1 plus 1 over the phi, right? Because P over A is equal to 1 over phi. So in order for us to get the phi, so we're going to multiply it by here. So by phi here to get the LCD. So we have here phi squared is equal to phi plus 1 because ma-cancel ito. So phi squared minus phi minus 1 is equal to 0. So in order for us to get the roots of this part, we have to use the quadratic equation. So the phi is equal to positive and negative b plus minus the square root of b squared minus 4ac over 2a. Here, The result of this part is RA is equal to 1, RB is equal to -1, RC is equal to -1. If we're going to substitute here in the alpha here, the phi, so negative times -1 plus minus the square root of RB here is -1 squared minus 4 times 1 times -1 over 2 times 1. Using the calculator, if we're going to calculate this one, the result of this is alpha is equal to 1 plus, this is 1 squared, plus minus the square root of 1 squared, 1, and this is 4, this is 1 plus 4 over 2, right? 2 times 1. So alpha is equal to 1 plus positive the square root of 5 over 2. So therefore, our golden ratio here is alpha is equal to 1 plus the square root of 5 over 2. So this is the golden ratio, and how do we come up with the golden ratio? So we have here the property of the golden ratio. So we have here the figure showing golden ratio. So we have here the Mona Lisa, the Parthenon in Greece, and the Vitruvian Man by Leonardo da Vinci. So these are the few examples, the figure showing golden ratio. So we have here, try this at home. Consider the sequence 1, 1, 2, 3, and so on. Fibonacci sequence. Find the 35th term and 58th term of the Fibonacci sequence using the formula. So this is the formula. So I'll just presenting you the formula. We have here Fn is equal to, again, this is the formula. So 1 plus the square root of 5 raised to n minus 1 minus the square root of 5 raised to n over 2 raised to n squared of 5. So this is the formula in finding the Fibonacci sequence. And the manual computations, you're going to write every terms. So that is your manual computation. So thank you so much for listening, everyone. I hope you learned something today. And don't forget to like, subscribe, and share to everyone. So God bless everyone. Thank you, and thank you so much. This is Kasaligan Vlog.